You are going to be taking a quiz on this material as well as all of the previous material. You'll be taking that most likely tomorrow. If not tomorrow, then you'll definitely take it on Monday. But what we're going to be talking about for today is point slope form. So we've already talked about standard form. That was the ax plus by is equal to c. We've talked about slope intercept form, which is y equals mx plus b. Now we have one more format that we're giving to you, which is called point slope form. And point slope form is utilized when you are given the slope and you are given a point, and then you need to be able to create your graph or equation from there. Okay, you also can be given just 2 points. If you're given 2 points, you can use point slope form because you can find slope from 2 points using your slope formula, right? y2 minus y1 over x2 minus x1. That would be your slope. And then you can use one of the points that's been given to you as the point for point slope form. Okay, so what point slope form basically is these, you've got your variables y and x, then you've got your slope being your m. So I'm going to underline that real quickly. M is always our slope. And then the y1 value and the x1 value, those are representing the points or the coordinates of a specific point. So you have your x1, which is the first value in an ordered pair, and then you have your y1, which is the second value in an ordered pair. And please make note of the fact that this is always going to be a subtraction here. This is one of the things that people get confused on the most, is that they think automatically that if the point is negative, that it's already subtraction, but it's not. Okay, so be very, very mindful of your negative coordinates. Negative coordinates are where most students make the most mistakes. So the equation essentially reads y minus y1 is equal to slope times the quantity of x minus x1. Okay, where y and x again are just variables. So we'll start off real simple. We'll start off where we're just given the point and we're given the slope, and then we're going to substitute those into that equation, the y minus y1 equals m times x minus x1. Okay, so here, knowing that our slope is going to be 3 over 2, so I know that my value of m is 3 over 2. Then I've got my value of x, because this is my x1. So x1 is going to be equal to 2. And then we've got our value for y1. y1 is going to be equal to 6. So then we're just substituting it into that equation that we had. So y minus y1 is equal to slope m times the quantity of x minus x1. And then you're just substituting all the values you know. We know that the y1 value is a 6. We know that the slope value is 3 over 2. We know that our x1 value is a 2. Okay, and so then we can just plug everything else back. Y minus 6 is equal to 3 halves times x minus 2. There's our point slope form. That's it. Okay, it's very, very simple. Now, from here, you can take this point slope form and you can then convert it into slope intercept form, because we typically like to have things put into slope intercept form. And remember, slope intercept form is in the format of y is equal to mx plus or minus b. Okay, that would be our slope intercept form. So essentially, you're just trying to get your y isolated. So if I take this equation that we created in point slope form, y minus 6 is equal to 3 halves times x minus 2. I want to go ahead and start solving it for just the y value. First thing that you always do whenever you see parentheses, we automatically know that we have to do what property? distributive. We automatically should know that we've got to have to distribute this value to each of the terms inside of those parentheses. So we're going to go ahead and do that. We're going to distribute the 3/2 to the x and the 3/2 to the -2. That means that you are multiplying. So we are doing 3/2 times x, and we are doing 3/2 times -2. Okay, 3/2 times x is going to give us 3/2 x, and then 3/2 times -2 is going to give us a -3. So we've just simplified this side. We still have y minus 6 on the other side though. Now I need to go ahead and start solving by isolating the y. The only thing that I can do to get y by itself is to get rid of this minus 6. How am I going to move the minus 6? Go ahead, Iker. Add 6 to both sides. So when we add the 6, can we add the 6 to the 3/2 x or to the -3? You only can add it to the -3, the -3, right? So we're going to add the 6 over to there. We can't add it with the 3/2 x because the x is a variable term, the 6 is a numerical term. Okay, so now we've got y by itself. Y is equal to 3/2 x, and then -3 plus 6 comes out to a +3. And there's your equation. Okay, so again, all we did is we took the slope that was given to us, we took a point that was given to us, and we put it in the point slope form first. Then we used that point slope form to go ahead and solve the equation, or simplify the equation into slope intercept form. Okay, and this just tells us again our slope is 3/2, which we already knew, and that we have a y-intercept at 0, 3. Okay, let me do one more with you. So example number 2, we've got the point -2, +3, and we have a slope of 4. Okay, so if I'm plugging this in into our equation, so here's my m. That's my m. This is my y1. This is my x1. So if I'm substituting it into that formula, remember our formula is y minus y1 is equal to slope times x minus x1. We're just going to start replacing things. So it's y minus, my y1 value changes to a 3, equals, my slope value is going to change to a 4, and then parentheses x minus my x1 value is going to change to a -2. Now here's the only thing. We do not like having double signs. No double signs. If you ever see double signs, you need to simplify them. If you've got one positive and one negative as your double sign, then it simplifies to a what? A negative. If you have a positive and a negative, it would simplify to a negative. If you have a negative and a negative, it would simplify to a positive. Okay, so just keep that in mind. A positive and a negative will simplify to a negative. A negative and a negative will simplify to a positive. Okay, and then of course, you know, a negative and a positive will simplify to a negative. Okay, doesn't matter the order of the positive and negative. If you've got one positive and one negative, it's going to come out to a negative. If you've got double negatives, it's going to come out to a positive. So you always want to simplify those double signs. So here's our double signs here. We have a negative and a negative, so it's going to simplify to a positive. So we're going to change that sign to a plus sign, and then everything else just stays the same. Y minus 3 is equal to 4 times the quantity of x plus 2 now. Okay? Okay, from here, we can then take that equation that we've got and we can convert it into our slope-intercept form. So we have that y minus 3 equals 4 times x plus 2. Again, first step, we need to go ahead and distribute. We're going to take the 4 and we're going to multiply it with the x and the 2. So 4 times x comes out to 4x. 4 times 2 comes out to a positive 8. So we now have 4x plus 8 on this side. And we still have our y minus 3 on the other side. Okay, still need to continue isolating. So our inverse operation of subtraction is addition. So we're going to add 3 to both of the sides. And you get your simplified equation. Y is equal to 4x plus 11. I want you guys to go ahead and try example 3 on your own. Let's see here. You should have gotten for your final answer y is equal to negative half x plus 3 halves. Okay, so again, here's your slope. Your slope was negative half. Your y1 value was a positive 2. Your your x1 value is a negative 1, so we substitute those in. When we get the double negatives, we simplify it to a positive, and you get the point slope form y minus 2 is equal to negative half times x plus 1. Okay, then you would distribute the negative half to both sides, and that would become negative half x minus a half. Then you would add 2 to both sides to get that positive 3 halves. Yes? Always leave it as improper fractions from this point on, only because when we're doing slope, you don't plot slope with a mixed number. It has to be a fraction form because it's rise over run. Okay, so always just get in the habit of leaving it in its pure fraction form, not mixed number form. So either proper or improper. Okay, and again, don't convert to decimals unless it's asking you to, or unless the answer choices that you're given are in decimal form. Just leave them in their fraction form. Okay. All right, let's go on over to the next page. So for the next page, examples 4 and 5, and then 6 and 7 as well, they are not giving you the slope. So you're actually having to identify the slope first before you can move on to doing the point slope form. So remember our slope formula. So write that up at the top because I'm sure some of you have forgotten how to find slope. Slope formula is just a subtraction problem of y2 minus y1 over x2 minus x1. So you're taking the difference of your y's over the difference of your x's. Okay? And order does matter. The way that you subtract your y's will determine how you have to subtract your x's. Okay? A lot of times kids get in trouble because they are subtracting in the wrong order for one of them and in a different order for the other. So be very, very careful about which one you assign as your x1 and y1 and which one you assign as your x2 and y2. Okay, so for here, I typically would just say, let the first point be your x1, y1, let the second point be your x2 and y2. So I'm going to find my slope first. So I'm going to let this be x1, this is x2, here's y1, and here is y2. And then I will find my slope. So we're going to subtract. I'm going to do 9 minus 1. And then I'm going to do negative 2 minus 8. Okay, when I've done that subtraction, 9 minus the 1 is going to give me a positive 8. Negative 2 minus negative 8, or sorry, negative 2 minus 8 is going to come out to a negative 10. So when I simplify, it's just negative 4/5. That's my slope. The negative does not have to be assigned to the top or the bottom. It can just be placed out in front. All right. Now from there, I can then go ahead and put it into my slope intercept, or my point slope form. So point slope form, again, is y minus y1 is equal to m times x minus x1. And so I'm just going to substitute through. So I get y minus. Now, it does not matter which one of these points I pick. It does not matter at all. I'm going to go ahead and just pick the point that I have first. I'm going to pick my x1 and y1 point first, but I'm going to show you that it works with either point, that you'll still get it in the same format when you simplify to slope-intercept form. So let's just use this point first. So we're going to subtract a 1 equals, my slope is negative 4/5, and then x minus my 8. All right. So I'm going to borrow a little piece of paper because I don't have a whole lot of room to show it on here. But off to the side, what I'm going to do is show you that this y minus 1 is equal to negative 4/5 times the x minus 8. If I were to go ahead and do my distributive property, you don't have to write this part down. I'm just showing you that it's going to be the same no matter what. When I distribute, this is going to become y minus 1 is equal to negative 4/5 x. Negative 4/5 times a negative 8 is going to come out to a positive 32 over 5. Okay, then I'm going to go ahead and add 1 to both sides. When I add 1 to a fraction, it's the same thing as adding the denominator over, the numerator being the same thing as the denominator. So 5 over 5 is the same thing as a positive 1. Everybody understand that, right? Okay, 1 over 1, 2 over 2, 3 over 3, 4 over 4, 5 over 5. They're all the same as just one whole. So essentially, I'm adding 5 over 5 onto there. So y is going to be equal to negative 4/5 x plus 37 over 5. Okay, now, if I decided to use this point instead, so instead of getting this as my point slope form, if I used this as my point, that would become y minus 9 is equal to negative 4/5 times x minus negative 2. Nope, I'm just showing you that it doesn't matter which one you use. It will come out to the same when you simplify to this format. Okay, so first things first, I have double negatives. So this is y minus 9 is equal to negative 4/5 x plus 2. When I distribute, I get y minus 9 is equal to negative 4/5 x minus 8 over 5. I'm going to then add 9 to both sides. When I'm adding a 9, that's the same thing as saying I'm going to add a 45 over 5. That's the same thing as saying I'm adding 45 over 5, because 45 over 5 is 9. Okay, and negative 8/5 plus 45/5 is, lo and behold, 37 over 5. So again, it does not matter which one of those points you pick. It's going to simplify to the exact same slope-intercept form. Now, since I did not have enough room to be able to write slope-intercept form or show how to solve it, I'm just going to go ahead and put down, this is what slope-intercept would have looked like. So our slope-intercept form was negative 4/5 times x, or sorry, not, I shouldn't have had the parentheses. Ignore that parentheses there. Plus 37 over 5. Let me find it here. We're ignoring that parentheses. Yeah, whiteout. Every so often, you got to use it. Whiteout. There you go. All right. I want you guys to go ahead and try problem 5. You can also do problem 6. We'll skip problem 7 just for sake of time. We'll skip number 7 and we're going to skip number 8 for sakes of time. I want you to do example 5 and example 6. Example 6, even though it's a table, it's still like you have 2 points. You just pick 2 points to find your slope, and then pick one of the points for your slope-intercept form. Yes, you need to solve it in the slope-intercept form. Okay? Let's go over this real quickly. A lot of you, I think we're coming up and asking questions or struggling a little bit with the slope on this one. Please be mindful, guys, that when you are doing slope and you are subtracting, so if I'm going to take this negative 12, I'm going to then subtract a negative 8. Some of you were, again, you were only putting minus 8. Be careful about that. It's not minus 8, because if it's minus 8, then you're saying that 8 was positive. Okay, 8 was not positive, 8 was a negative, so it's subtraction of a negative 8. You could have also done negative 8 minus negative 12, depending on the order that you went ahead and did it. So based off of the order of how I did it, though, I then have to do negative 5 minus negative 2. Okay, again, the order that I've set up the first one determines the order that I have to set up the second one. When I subtract negative 12 minus negative 8, that's going to come out to a negative 4. Negative 5 minus negative 2 is going to come out to a negative 3. And then negative over negative simplifies to a positive 4/3. Okay, when I am subtracting, so I'm not going to rewrite the whole thing again, y minus my y1, I'm just going to go ahead and let this be my y1. So I'm going to subtract a negative 8 is equal to my slope, which is 4/3, times the quantity of x minus my x1 value. I'm going to let this be my x1 value. That was -2. Again, I don't like having those double negatives. I happen to have a double negative here and a double negative there. So I do not like having those double negatives. I'm going to change them to positives so that we have y plus 8 is equal to 4/3 times the quantity of x plus 2. Please stop. Okay, again, if you use -5 and -12 as your point, then it should have been y plus 12 is equal to 4/3 times x plus 5. Okay, that would have been your point slope form. Then once you solve it into slope intercept form, everybody's slope intercept form should have been y is equal to 4/3 times x minus 16/3. Everyone should have gotten that. Okay. For example 6, with example 6, you just had to find the slope by doing your change of your y's over your change of your x's. Shh. So for here, I wind up subtracting it by 6. Then this one is subtracting by 15. This one is subtracting by 6. That's okay that they're a little bit different. They are still proportional. Stop talking. Here we are going to be adding by 2, then we are adding by 5, and then we are adding by 2. It all comes out to the same thing, that our slope winds up being a -3. Okay, it does not matter which one of these that you would have chosen. If you would have chosen the -6 over a +2, it is the same thing if you had chosen to do your -15 over a +5. They all are going to come out to equaling -3 for your slope. So there's your slope. And again, you just pick one of these points. It doesn't matter which one you pick. I went ahead and chose just the first point. I went with the very first one because it's there. And so I would have gotten y minus the 14, because here's my y1. So y minus 14 is equal to -3 times the quantity of x minus, and then my x1 value is a -4. Again, we do not like having those double negatives, so change that double negative into your positive. You get y minus 14 is equal to -3x plus 4. Okay? Then once you solve it in slope-intercept form, that would become y is equal to -3x plus 2. Any questions? All right. We're skipping 7 and 8 because I really want to get to the very back. So for here, talking about special line equations. Special line equations, so if you have lines with an undefined slope, if they are telling you that you have an undefined slope, then what this means is that you have an x equation that's equaling your x1 value. So instead of it being y equals, it's x equals. If you have an undefined slope, you have an equation of x equals and whatever your x1 value is going to be. So the reason for that is, who remembers an undefined slope is what kind of line? It's a vertical line. An undefined slope is a vertical line. That's what an undefined slope looks like. It's a vertical line. So that means that while all your y values are included, you are always stuck at one single value for x the entire time. Wherever your vertical line is, you are always stuck at that x value. Okay, your x will never change, but your y will be all numbers. So it's x is equal to whatever specific value your x is. So in this case, our x is a 5. So therefore, our equation is x equals 5. For problem 2, our x value is -6. So our equation is x equals -6. What's the equation for number 3?
X equals 4.
X equals 4. What's the equation for number 4?
X equals 5.
X equals -5. Okay, it's so difficult, I know. These special lines are super, super hard to do. All right, what about with zero slope? If it is zero slope, what kind of line does zero slope look like? A horizontal line. Okay, when it is a zero slope, it is a flat horizontal line. So that means that all x values are possibilities, but you only have one specific value that your y can be. So that means your equation is always going to be y equals whatever your y1 value is. Okay, so for here, our y1 value is a 9. So our equation is y equals 9. What's the equation for number 2?
Y equals 7.
Y equals 7. What about number 3?
Y equals -3.
Y equals -3. What about number 4?
That one's too hard.
That one's too hard? Okay. Yeah. All right. You have a delta math. Delta math.